This is part 2. Part 1 ended somehow accidentally, but I continue anyway. Now our goal looks like for all something something, so I use the for all introduction rule. Now I have more assumptions. S is a natural number. Depending on if this S is 0 or not, our goal is different, because when it's 0, our our EVM implementation is out of fuel, and in that case the program execution enters this program step run out state. I have set up the goals so that that's allowed, when our EVM implementation runs out of fuel. That's not the contract's problem, so that's fine. I can remove this. This part, this part can be automated. When the execution is out of fuel, that's fine. I repeat saying that until I meet some sort of problem. What is the problem we are facing now? Maybe it's easier to see this way. Program execution at this point. So our stack has one element, data size, blah blah blah. I guess this is too big and this can be simplified. So I say, well, let's look at the definition of data size and use that thing. Now it's slightly easier. Our data size is the length of the data sent. Okay, let's further simplify our goal. Now it looks much simpler because our stack contains, oh yes, just length of something followed by nil. I have to sometimes interact with the proof assistant to convince that it's still fine, or what actually happens is the proof assistant is fine to execute some opcodes until it's not sure what's the next state, and then I have to use definitions and lemmata to simplify the current state so that our EVM implementation can continue until it actually finishes. So this is lengthy, but actually our program has finished running, and it has finished running exactly the way we have specified it to be. We have another goal. This goal is about the remaining state of the account after this execution. Maybe this part is less interesting, so I just skip it. Since we did a case analysis on if data is nil or not, now I have to deal with the case where the input data is non-empty. But what I do is essentially the same. I have an assumption, so I introduce it into the context. I do more case analysis on the sent value, and then again I have an assumption. We are now dealing with the case the value is 0. That's also in our context now. And now everything looks like an if sentence. Okay, not everything, but we have a big if sentence. So I want to do a case analysis on this formula, if this is true or not. I do that. Now I have two goals. When this thing is true, or when this thing is false. And when that thing is true, the data is too short, and the contract should fail. Now we have an assumption, contract action, contract fail, something should be contract action act and cont. Actually, this act thing should be contract fail, and this cont thing should be equal to this managed account with accumulators. I can make that happen. Now this cont variable does not occur anywhere, it's replaced with the concrete value. And then I use the same thing. I just say figure out the exit thing. I say, okay, let's follow the execution as far as you can, and when it's in doubt, it comes back saying the current state is too complicated. In this case, we are seeing an if sentence, but actually I can say this if should be false. So I use that, and the goal is simpler, and the proof assistant can continue execution of this thing slowly, but still we can do this. And again, we are seeing an if sentence. The proof assistant is not sure if this is true or not, so it cannot continue. But actually, we have sufficient assumptions to conclude that this is true. I tell it, and then the program state is easy enough for the proof assistant to continue its execution. And again, okay, we are seeing some more if sentences, and the proof assistant is not sure yet if it's true or false. I tell it it's true, and then the program finishes, and I can finish the proof. In this case, the remaining state is easy because when the contract fails, the resulting state should be the same as the original. I do this for every program execution path. When the data is big enough, when the owner is correct, when the caller is the owner, when the caller is not the owner, somehow I can continue doing this. It's just a repetition. It's very lengthy, but it's just because of many cases. And the proof assistant is happy to check the proof script. And then I can finish the proof with QED. In this case, the proof assistant should be happy. Yes, it's happy, but sometimes it says a big no at the end of QED, especially when you are doing a co-inductive proof. I think I should explain about this co-induction thing in the next video.